yours. Yeah, hello everybody. Again, those of you that were yesterday, it seemed to work pretty well. I've tried to find out a better way to deal with the slideshow. Let's hope that it works better than yesterday. And those of you who were not yesterday, welcome to today's session about the Movesense mobile programming. Let's see, I'm going to share with you the screen. And here we have the presentation, and if I can find the present button here. So the session, this one needs to go away. The session for today is the Movesense mobile programming. That is the subject, and let's see how it goes. And of course, that didn't work. Let's try again. Again, we have a full table of contents here about different subjects. I'm hoping that it will be not any longer than yesterday's session. That leaves us more time for the questions and answers. First, I'm going to say a couple of words about what is Movesense in general, just like yesterday. Then I'll take a quick look on the Movesense mobile architecture. Go a bit more detail to the Movesense REST API. That's also from yesterday. Then looking into detail on how to add our mobile library called MDS into your Android project and how to connect to sensors, also Android. We do have iOS support as well. I'm going to go through the Android because that's the side that I know. I don't have the full iOS development environment set up on this laptop, and I'm not too familiar with it. So I'll look into the Android side. iOS works pretty similarly, and I have a session, kind of section of that in the end of the presentation. Then looking into how to make MDS requests. Then a small slide about how to deal with the sensor firmware updates, which is kind of thing that if you make your own mobile solution, you will need to know. Then session about using the data memory from mobile side of things. And finally, a bit about the iOS programming. And then we have the questions and answers session, just like yesterday. When you can ask your own questions, if something is unclear or something, just put the question immediately to chat. We'll try to answer those as soon as we see them. If we don't answer immediately, don't worry. We'll go through them in the Q&A session in the end and make sure that everything gets answered. So, without further ado, let's continue to the actual content. First of all, what is Movesense? And a short answer is an open wearable tech platform. It comes with a programmable sensor, which we covered yesterday, mobile SDKs, which we covered today. It comes with this embedded REST communication framework called Whiteboard, which glues these together. And that is kind of one of the big strengths in the Movesense platform. And then it comes with the physical accessories like heart rate belts, attachments, smart connectors, etc. Now to the actual mobile side. The mobile architecture of the Movesense, it basically can be seen in our picture on the screen. And on top of on the mobile phone, we have a user application. That is your thing. That's what you do. Then you're free to use an optional third-party framework. There are several of them, like Xamarin, Unity 3D, React Native, Flutter, and a couple of others. And for some reason, this keeps jumping up again. Really hate this. Then under the third-party framework, you have other third-party libraries that you might want to use. On Android side, you have RX Android BLE, or you can have it. It abstracts some Android BLE things and makes it work better under different mobile phones. Otherwise, you may have to do some kind of jump through some hoops yourself. Especially with older OS versions, there was quite a lot of variation between different phone manufacturers. Another thing that you probably will bump into is the Nordic Semiconductor's DFU library. And that's what you use to make the actual firmware update on the sensors. Then underneath everything else is the operating system layer and libraries, which of course your application is free to use. Nothing prevents it. Unless you, of course, use some kind of third-party framework, which kind of goes between those. And as I said, mobile frameworks can be used, like Xamarin, Unity 3D, React Native, Flutter. I'm sure there are many others. Those are the ones that we know that are active at the moment. Now, the thing is with the Movesense sensor is that all the activity on the sensor, all the functionality of the sensor, whether it's a data from accelerometer, whether it's a heart rate detection from the Maxim chip, whether it's a temperature sensor, whether it's the data memory, whether it's putting it to the DFU mode, everything works through a REST API called Movesense REST API. Many mobile developers are very familiar with the REST APIs from the internet. This is very similar, it just uses a different piping underneath to be efficient on the embedded devices, like our Movesense sensor. The Movesense REST API has been split to a few main sections. There's the MEAS for sensor data, accelerometer, gyro, temperatures, heart rates, ECG. There's the MEM for handling data memory access. Underneath the MEM, you have data logger and logbook. We'll get to those later. Then there's the /com, which is for communication protocols, BLE one wire. BLE you probably will not use over the mobile, over the BLE. It doesn't really make much sense to, for example, switch off a BLE connection by telling the sensor to cut it off. However, the one wire can be very easily used over the mobile, over the Bluetooth connection, so that you can, if your Movesense sensor is attached to external one wire components, you can easily use those and communicate with those by using the Movesense one wire API. Then we have component for low-level features, switching on and off the LED, accessing the EEPROM. You can, for example, take full EEPROM data dump from mobile phone, no problem. And there are certain chip-specific features that are exposed in the low-level APIs. Then there's the system, which is for all kinds of system features. System mode is the most important, which is basically tells your sensor to go to a firmware update mode or reset straight to the application mode if you want to run the reset from the mobile side. You can also get the battery level using the Energy API and check how much memory is available on the sensor, states whether the sensor is moving or not, whether it's somebody is touching the studs or not, that kind of things. Then we have UI for user interface, which is kind of higher level LED blinking API. Miscellaneous for the rest of the stuff, like reading the smart connector ID that the sensor is attached to. And then whiteboard for whiteboard specific stuff, but that is not really handy or needed for anything from mobiles. To read the actual API definitions, you can go to the link below in the Movesense device library, Movesense device library, and read them in the Swagger 2.0 notation. A little bit extra about the measurement interfaces. or any interface that gives kind of fast data which has a sample rate, like accelerometer or ECG. We have an info, which lists information that is useful, like what are the valid sample rates, what kind of sensitivity values settings can you put to the chip, like G range in the accelerometer. Then we have config, where you can set the sensitivity or whatever configurable parameters for that sensor there is. And the actual data you get from MEAS / let's say ACC / and then you just put the nominal sample rate that you got from info. And after that, then you start getting the events when the data is available. Now, this is Android specific, as I said earlier, but there is a way to do this in iOS. Please, for iOS, if you are using just iOS, go look at our Showcase app. The source code is available. You are free to modify it for your own use. It's open source, so use that. But many of these concepts are very similar in the iOS, so you have to do pretty similar things there as well. So let's go through it on the Android side. First of all, for the Android project to use the MDS, you need to add some libraries into the project file, which is Gradle file in the Android Studio. You need to add, let's see if my mouse is visible there. Yes, it is. I just don't see it on my screen. Slightly higher. There's one row where the pointer is now, which lists the MDS library. That is kind of the big thing. If you don't have that, you don't have MDS. Then above it, I've also taken a screenshot of the RX Android BLE library and a couple of other libraries that one depends on. Those are important in the sense that the MDS for Android is using the RX Android BLE for talking over the BLE to the sensor. So you need to add those. And the best way to get the correct versions of those libraries to your own application is to look into the sample projects that we have in our Bitbucket. Those will always have the versions that the current MDS library has been built with, so that you don't have version incompatibilities between them. Then I added the JSON. It's a Google's JSON library and parser that is actually very handy for parsing the JSON that the MDS library is returning. Then when you have those included in the project, you need to create the MDS object that you then use to talk to the sensor or to the MDS library itself. Here, you call MDS builder build and you give it the context. The context is any activity or the application or Android service that you have handy. Word of warning though, the context needs to be valid for the duration of the operation. In our sample files, we've taken the easy way out, and we have done it so that the context is the activity, aka the view on the screen. But for example, every time you rotate the screen, if you have the auto rotate on, it destroys the view and recreates it. So that would break the application and it will result a crash. So in our samples, we have easily avoided that by preventing the rotate from working. In actual production application, I would actually recommend that you do a custom application object and you give that one to the MDS class as the context. That application object is then valid for the life cycle of the whole application. Then, about connecting to the sensors, there's a bit of connection logic going on inside the MDS. But before you can actually even start to connect to the sensors, you need to know the device ID or in case of Android, that one is the MAC address of the Bluetooth device that you want to connect. Of course, you may know it already from you've written it on a piece of paper or something like that, and you just want to connect to that specific sensor. Then you don't have to do the scan if you don't want. In iOS, the operating system assigns a unique ID, temporary unique ID for that device when it first is encountered, and that stays constant until I think the device is forgotten by the iOS. Somebody removes it from the list of known devices or something like that. I'm not 100% familiar how it works in the iOS in the latest version, so that's about as specific as I can get. In Android, we get the MAC address. In iOS, it's some kind of complex ID that you use. And the scan is not part of MDS functionality, so feel free to use whatever API you want or like for scanning for Bluetooth devices. In Android, your application have to have location permission so that the scan actually returns any values. If you don't have the location permission, then the scan results no device is found. You'll just get an empty answer, no callbacks at all. So that's part of the Android security things that you have to take into account. If you try one of our sample apps, they have a code that then asks for the location permission the first time you use the app. Then when you have the MAC address or device ID in case of iOS available, then you call the connect on the MDS object, and you give the MAC address, aka device ID, to that connect call. The second parameter is a listener object that you create, which is of type MDS connection listener, and that then has methods that handle the status callbacks that the MDS gives you when things happen. And what your application then must do is to act on those callbacks on the listener object, which you implement there. We have onConnect, basically means that the BLE connection is okay. It means nothing else. So the BLE connection, the operating system can actually talk to the sensor. Then the important one is the onConnection complete. That means that the rest of the communication stack, being the whiteboard, that has a good connection. There might be a long time between those two, especially on the first connection, and especially if the BLE is very slow. For example, you have a very old phone or something. Then that during that phase of the connection, there's lots of metadata being exchanged, especially on the first time, between the sensor and the mobile phone. Then there's the on error, which tells you that something went wrong, and on disconnect, which means that the Bluetooth disconnect happened. The disconnect can happen for many reasons, and that is where the thing usually goes haywire, is that the disconnect can happen if the sensor goes out of range, if the sensor runs out of battery, if somebody has a leaky microwave oven and it's switched on, if somebody accidentally puts your sensor into the microwave oven, or if you actually call the disconnect method on the MDS object yourself. In any case, you get the on disconnect when the disconnect happens. And if you did not call the disconnect yourself, that means that the MDS will try to reconnect automatically, at least on Android. I'm not 100% sure how it works in iOS. So assuming that somebody accidentally put your sensor to the microwave and did not switch the microwave on, it went out of the radio range, and you get it back, and you open the door again, then there's automatic reconnect happening between the mobile phone and the sensor, and you'll get again on connect and on connection complete callbacks. So that on disconnect, on connect, on connection complete, on disconnect, so on loops, those callbacks can happen many times during the life cycle of the application, even with the same sensor. Then small explainer why I'm talking so much about the microwave oven and somebody putting your sensor in there. I found out personally that that is the best way of trying out if your application has the disconnect functionality implemented correctly or not. So when you try out the samples that we have connectivity API sample, which is about the most simple application you can make that talks to the sensor. Then with that one, you can easily try it out by connecting to the sensor, looking at the UI. Yes, it made the connection, and you can get the information from the sensor from the UI. And then when the connection is there, you just take your mobile phone and you take your sensor, put the sensor inside the microwave oven, close the door. Don't press the power button. And then what happens is that in a few seconds, the phone will notice that the sensor is no longer available, and it will show up as a disconnect. As soon as you open the door, second or two, and you'll have it connected again. Then I was talking earlier about the REST API. And just like in the internet, you do requests to the REST APIs using the kind of common verbs of the HTTP. We have get, we have post, we have put, we have delete. And we have tried to make it as REST REST style API as possible on the sensor. So we have resources which are in paths described in the YAML Swagger files. And then we have these verbs, and we tell the MDS to use these verbs on those resources. And let's see if I can. There's a bit of lag here, but yeah. Here, for each REST verb, we have a method in the MDS object. And in Android, it's in lowercase. I don't know how it's in iOS. For example, REST verb put has MDS put, etc., etc. And all of these get, post, delete, and put, they work the same. You give it as a parameter, you give it URL to the resource. You give it optional parameter object. For example, if you just want to do get, you don't need to put the parameter object unless the API defines that you need to have one. Then for a result and how the things actually turned out, you will have to give it an MDS response listener object, which again has a pile of callback functions that MDS will then call asynchronously and give you the results of your request. The URL format that we have used on the MDS is built in the following way. It starts with the word Suunto, which is our kind of parent company here, couple of colon, couple of slashes, then the device serial number, and then slash and the resource path to the service on the sensor. The device serial number you will get on the on connection complete callback. So when you have the whiteboard connection on, the whiteboard will find out what the serial number of the device is, and you will then attach it to the URL. You can build your URL with the serial number, and then you can do it. Parameter object is simple JSON. It's a JSON string that you just give to the method, and the parameter name and the structure of the object as a JSON that you give it are defined in the YAML Swagger definition file. For example, if the YAML for verb get would define that it would have an object called query that has a certain structure, then the parameter name would be query, and then the object would follow that structure that is defined in the YAML. If you don't put that correct, you will get the error 400, which is bad client something, bad client request, I think. And for examples, I'll show you. there's a connectivity API sample. I'll put it full screen, hopefully, and then I'll try to, can I zoom in the text a bit bigger? It's quite small font, so I would hope that I get it a bit bigger. Is it in a window? No. Tool windows appearance, maybe. No zoom here. That's not nice. Well, I hope that you can see the text here. So this is the Android connectivity API sample Android project. Show a rest of the call example in an Android setup. Yeah, I'm going to have the REST call example right here. I hope that you can see it here. You can always go and look at the same source code. This is part of the samples that we have in the Android section of the Movesense mobile library. Yeah. Okay. Let's see. We go to the Here we have the main activity. This very simple app just has in the onCreate we call the init MDS, where we create the MDS just like I showed in the cliplet. We have code that requests the needed permissions. You can just copy paste this to your app. Okay, scan device information. I think click. Okay, here we have a method that does the connect to the PLE device. So first I'm checking the scanners, asking the BLE device object, and then I'll get the MAC address from that so that it's in the same format. And here I do the MDS connect, give it the MAC address, and give it the connection listener object. This is very simple. In the connect, I just tell that, okay, let's log something, that something happened. And now here we have scan array list, scan result array list. So when the whiteboard connection is complete, we'll mark on that list the object as connected. Basically adds a couple of asterisks around the name of the device. On error, just shows an error dialog, and on disconnect, which has, when it happens, we mark it disconnected, which removes those 3 asterisks. And then, of course, then we have on the item long click does the disconnect, and here we have the first get verb. We have get function, MDS get, and that happens when the show device info is called, and that one is actually, I think you just tap a connected device on the list. I'll show you too how it works in a moment when I put it to the, I'll share the mobile screen for that. We give the URI, which is built from the Suunto : / device serial number and /info. That tells the device information from the sensor. We just give it that URI. We don't give it any parameter object, and we give it response listener. Here, we just, on success, we receive a JSON string telling that, okay, this is what the sensor returned. And here I just make a simple dialog that shows the JSON to the users. And now, in case of error, I just print it out. So let's see if I can. No, that's Why did it change? It has zoomed out. Let's take it a bit smaller. Here's my mobile phone view. And let's run this. Do I not have the debugging is connected? File transfer turned on, it should be there. New laptop demo effect. Sorry about this, I'll put it installing in the background. Okay, I can show you this a bit later. And now I have to continue the actual, no, wrong one. This one. But as you saw, it's just giving it the URL or URI, giving possible parameter object if you want, and then having the callbacks, result given to you in callbacks. I'll zoom that one out. Then the MDS API has a thing called subscriptions. It's basically an extension to the standard REST things, which tells that describes a subscribe, unsubscribe, or the publish, subscribe, publish, consumes, publish, subscribe pattern. So services can subscribe data streams, and the clients, in this case the MDS, can subscribe to those data streams, and they get asynchronous notifications whenever data is available. Basically, all our sensor code works that way. All the sensor data streams come as listeners, come as events. And that has been implemented the following way. In the MDS, we have the MDS subscribe call. And that takes a couple of parameters. First of all, just like the other calls, it gets a URI. But in this case, the URI is to the internal MDS service called event listener. And then we give it a contract object, which is a JSON string, which has just one property called URI, and you will give it the URL that you want to subscribe on the sensor. Then you give it MDS notification listener object, and that will define all the callback methods that you can override the callback methods so that you can get the data back. And it returns an MDS subscription object, which you can then unsubscribe when you're done with the subscription. In the notification listener, we have two callbacks: on notification, and then it has one parameter called data, and that data is event data as JSON string. So all the time we get the JSON string, and especially when getting numerical data and complex objects, it is very handy to use, for example, the JSON to parse it as a Java object, or in case you are using some other programming environment, parse it to an actual object, and then you can get the data much easier and handle it much easier than trying to parse it by hand. And there's on error in case something goes wrong with the subscription. Quite often the subscriptions work, but not every time. There could be, for example, you have just performed subscribe and suddenly the Bluetooth connection goes down. Then of course the subscription will never be finalized. And to end the subscription, call the unsubscribe method on the MDS subscription object that the subscribe just gave you. And one thing to notice is that if there is a disconnect happening, all your subscriptions are invalid. Which means that if suddenly you put your sensor to the microwave oven, then after that you reconnect the sensor it doesn't mean that the data streams will start coming again automatically. You have to redo the subscription. So that is up to the application developer to do. MDS does not do that automatically. Let's see if my installation has done. Not yet. So let's continue. We have a simple example for subscriptions is the sensor sample application that we have under the end. I can show you actually a list of these samples. You know this device library, we'll call it the mobile library. You go into the Android samples, and here we have connectivity API sample, sensor sample, which just subscribes to an accelerometer and gets the data from that. Then there's a bit more complicated ECG sample. I think it has a graph or something that it updates. And then we have the data logger sample, which is the most complicated of them all. And I'll go into more details with that later on. Okay, let's see. Okay, this one is done. Now it's building. And still building. Oh, this is slow. Didn't expect it to take this long. Well, hopefully it's after the first time it's fast. Okay, something happened. Now I can. That's loading devices. Yes, allow debugging. Now my phone is here. I can click the debug button. I'm still building. I have here on the left side of my screen. Sorry, this way around. Left side of the screen, I have the sensor on the jig powered up, which has the yesterday's Blinky sample running. Okay. Looks like I have this application from some earlier build there. Yes, please override. Just waiting for debugger. Okay, there's a question on the chat. Registering events. I think we have to look into more detail on what that is about. Now, as you can see, the connectivity sample asks for the location permission. We allow it. Now I have scan here. I click it. And this port 10 here, the bottommost one of these is the one that I have here blinking. I click it. Now it started. As you can see here, there's lots of traffic going on. In the debugger, view, you can see a lot of stuff. And we actually got connected. And as you can see on the here, the sensor got marked with those 3 asterisks on both sides. Now, if I tap that highlighted entry on the list, we just did that get query to the sensor, and we got the information of that sensor, and we printed it to the screen. In this case, it shows that it has that serial number, it has certain name and so on. And disconnect. Let's do it so that I now power off the sensor in the jig. I take the power off. 2, 3, 4. About 4 seconds. And we got the disconnect event, and because the sensor disappeared. I'll put the power back on, and we just redid the connection, and now it was quite a bit faster than the first time. And when we want to permanently disconnect that sensor and we don't want those callbacks again, I do a long press on the list, and we did disconnect. And after that, there's no more connection and no more automatic connection going on. Then let's see the subscription. We have here the sensor sample. It's otherwise identical. Samples, sensor sample. Except here, I'll hide that one. We have an extra method called subscribe to sensor, and here we do the subscription. Here I'm doing the contract with the string builder class. I give it the URI property and construct it based on the connected serial number. Then the MEAS ACC13, which is the slowest accelerometer data. And basically, we call the MDS. In this case, we build it live, slightly different pattern. We use the event listener URI, like I showed in the slideshow. Give it the contract that was constructed above, and then give it the notification listener. And here, in the on notification, we log out the string. That's always a good practice in the beginning, so that you know exactly what data you are getting. And here I use the JSON library to convert it to an ACC data response class. It's just a simple class that has the same structure as the JSON object we are getting in, and the parser can automatically fill in an object for us. And assuming we got the response object and it had more than 0 samples, then I'm creating a simple string with the X, Y, and Z coordinates of the accelerometer value, and I'm filling it up on the UI. And I'm killing on the phone the connectivity API sample, putting it back. And let's see how this one works. Nothing to show. This one also was missing something. Maybe I have to kill this one and open it again. And now it woke up much better. Let's debug it so we see what's happening. The sensor data. Yes, I want to overwrite. Here we have the debug window. No, this is the other. Debug. It's launching the app, and we need to unblock it. Same thing, we allow the location. We scan for our 410. We found it. Same thing, tap to connect. And the first connection takes a bit longer than the rest of them. Now here we have on the list that click on connected device and it will subscribe to accelerometer data, which is shown on the screen. Let's do that. And there we have it. If I turn the sensor on its side, you see that it went to the X coordinate, and now it's on the Z coordinate again, about 10 meters per second square. Unsubscribe, disconnect. I'll just kill the application. So this is basically how you use the, where did I leave it? There. How you use the the MDS requests, whether subscribing to a data stream or whether get, post, put, and delete. In iOS, it is very similar. The JSON objects look exactly the same. There's the same code underneath both iOS and Android MDS that does the JSON. Then, after you know how to access MDS and you have your sensors and they're working, at one point you will be wanting to update the sensor firmware. And the actual update process is actually run by Nordic Semiconductor's DFU library. I put down there in the bottom of this slide, I put links to the DFU libraries that I found. There's an Android version, iOS pods library, React Native version, and Flutter version of those same libraries. So, or at least those you have direct, just drop in library for using those in those environments. But before you can actually do the update, you have to put the sensor to a DFU, which is device firmware update, DFU mode. And in case of in the Movesense, that is done by doing a put in the system mode service with the parameter new state 12. The possible states are listed in the YAML file for that API. Basically, the only things that you have to remember is that I think number 1 is power off, or full power off. Number 5 is the application, and number 12 is the firmware update. And you can see the firmware update on the sensor because the LED switch is on. And if it's a bit older sensor with 1.9 or older software, it will stay in that mode indefinitely and burn your battery in the process because the LED use 1 milliamp. So maybe a few days later, you will have an empty battery. Or if you have a 2.0 version of software on the sensor, then it will be with 2-minute timeout. If there's no Bluetooth connection, it will reset back to the application. Then at some point, especially if you double with the sensor software development, you will have a sensor that crashes as soon as it starts. And for that, we have something called DFU recovery mode, which requires you to touch the studs behind the sensor while inserting battery and looking at the blinks and taking the fingers off so that you can actually manually put the sensor in the DFU mode, even if your own software does not start properly. But basically, the rest of the process is handled and described by the Nordic's DFU library. You get some kind of callbacks from it, and you can update the screen on it. We have it implemented in our Android Showcase app and we have it implemented in the iOS Showcase app as well. And the source code is available, so you can look into that, those implementations and see how it goes. I have not personally done that, so I cannot explain it too deeply. But that is how to do the DFU update. Then one thing that was asked by quite a few of you was how to use the data memory. And the sensor data memory, as I wrote earlier in the REST API section, there's two services. There's a data logger and there's a logbook. Logbook is for looking at what the logs are on the sensor. Data logger is for logging data to the sensor. Data logger is a very simple service which has two paths. One is called config, where you just give it the list of all the subscribable paths that you want saved. In this example that I have here, there's just one path, and that's called to the accelerometer at 13 Hertz. The word of warning, the maximum count for paths is 4, if I remember correctly. And the other thing is that if you have a lot of very fast data streams going in, you will swamp the internal memory bandwidth of the Movesense sensor. So try with something simpler first. And then there's another path called mem data logger state, and it has basically normal operation. It has two states. Number 2, which is ready, aka not logging, and number 3, logging. So you put the state to 3, and that means that the logging starts. You put the state to 2, and the logging stops. Very simple to use, nothing complicated. And we have very reasonable sample for data logger use on the Android side that you can try out, and I will show you it in the moment. Then how to manage the logs on the sensor. The sensor API has service under a couple of paths or resources under the logbook. One is called entries, and that enumerates the logbook content lists all the logs that you have there. It lists them at 4 at the time, so that it doesn't doesn't return too big object. And then it gives you HTTP code continue so that you do a next request with the starting ID and next request with a bigger starting ID and so on. It's quite clumsy. There's a better way on the next slide, so no need to do that. Then there's a post to entries, and that starts a new log. So the thing is that you can start a new log even while the logging is ongoing in the current sensor. And since you cannot transfer the logs that are being written at the moment or that are being overwritten to the data memory, because the data memory is small and it's a ring buffer shape, so it kind of eats its own tail when it's full, then that means that when you start a new log, that means that the previous one can be started fetching even while it's logging new data. And then when you are not logging, you can call delete to mem logbook entries, and that erases the whole logbook content and initializes the current log ID to 1. Then the actual log data is fetched with the get to the service called mem logbook by ID. And then you give it the log ID that you got from the logbook entries /data or /descriptors. So both of those binaries are needed. And again, it returns binary content in small pieces with the HTTP code continue. And that is a very clumsy way of handling it. So next slide has the better way from mobile side to do it. If you are operating inside the sensor like yesterday, then you have to use those. And here I have linked to the documentation on the Movesense site, which has more detailed thing about calling those logbook methods. But these are the on-sensor services. In the MDS itself, we have a data logger, actually logbook proxy service. And that one does a couple of things that simplify the logbook use a lot. You access them by giving it a URL that starts sudo : //mds instead of the typical / serial number. And under that you have logbook and then the device serial number and entries. And that takes care of the paging of the entries, and it takes care of retrying in case of errors. And it returns you the whole data logger entry collection as one single JSON object. It takes a bit longer, especially if you have a lot of very small logs. The scanning is quite slow towards the end of the memory, but you'll get the whole collection. That's getting the entries, so use this one instead of the raw entry collections from the sensor directly. And then we have the MDS logbook device serial by ID, log ID /data. And this is very handy service because it basically fetches the logs descriptor binary, data binary. It caches the descriptors internally when it can, handles the retry logic in case there are transfer errors, and it converts the whole Suunto binary encoded message, stem binary blobs, and gives the whole log to you as a JSON string. Of course, if the log is big, the JSON string is going to be big. However, the modern phones, they have gigabytes of memory, and our data memory at the moment is maximum 384 kilos of binary. So even if you use the full log memory, data memory on the sensor, you will not get very big JSON file as a response. Here I will start the okay. How did this go away? Okay, like this. There. I'll search for the data logger on my phone. Same UI as the previous samples. I have the sensor on. I found it. I connect to it. And now this application, we can actually see what it's doing from the logcat window. There's lots of things going on here. Oh. And on the UI, hey, why did it not update yet? It's connected, but okay, I'll disconnect and reconnect to the.
Just commenting Andy's chat post here. So thank you, Andy, for being part of the meeting, and thank you also for your very useful contribution to the community with this Xamarin SDK that you just linked to the chat. So that's one of the tools that is very useful for developing these mobile applications. So anyone who's interested, just check the link that Andy posted.
Yeah, I've used it myself, and it's a very good framework to do work, especially if you don't like Java, because you get to code with C#. So that's very good contribution by Andy and Microsoft for Movesense ecosystem. But yeah, now I finally got this. Where's my mouse? There. I got this data logger visible here. As we can see, there's one single log. I'll click the erase logbook. Let's clean this screen here as well. Erase logbook. Confirms. And we just did it. And now there's nothing on the sensor data memory. It's all clear. We can select which path do we want to record. In this case, I would let's do accelerometer, gyroscope, and magnetometer at 52 Hz, all three of them. Like this, and start logging. And now I could disconnect the phone. The application can, when it reconnects, it will notice that there's logging ongoing, and it can find out what is the configuration, and it initializes the UI, and it shows us that the logging is ongoing. Where's my mouse? There. It shows logging. And now we've recorded some time. I stopped the logging. The sensor could have been away at this point. And we have here one log. And I'll clean up this one a bit so we can see as soon as I tap this log on the list, things going. The transfer is not very fast. It has been built to be more or less safe to do it. Depending on the system, it's a few kilos per second, the data transfer rate. We hope to get improvement in time for the big data memory variant of Movesense, and that one comes out so that then at least with that one we can transfer quite a bit faster. Oh, it looks like I recorded quite a bit of data. It's ongoing. I should have talked less and clicked the stop fast. Okay, and here we got. It shows on the screen, it shows the first few moments of the data. Was it 16 kilos maximum? We have arrays for accelerometer value, arrays of magnetometer values, and arrays of gyroscope values. And we have here a save button that you can click, and it goes to the saves it to the file system on the phone. Now, if we create a new log, if I would now start logging, it would continue on the same log. If I create a new log, now we get the current log ID is 2. I do start, I do stop, and we have 2 logs in the memory. And again, tapping the log. Now it was quite a bit faster because it was smaller. But that's basically how you can access and use the data logger from the mobile side, whether it's in your application or or using our data logger sample. The data logger sample, if you need to record, let's say, if you have a person swimming, he will be underwater, and there will be no Bluetooth connection to the sensor. So you can use this app to measure the movements while swimming, and then fetch it after the swimming cycle has been done and get it back. Or if you do something else where the person cannot have the phone with them all the time. The handy thing with the data logger and logbook is that it works even if there's your own application running on the sensor that provides its own data output. If your application, for example, calculates the orientation information from those IMU channels that I showed, that means that you can record those as well. There are some limitations what can be recorded, but you can do whatever you want as well, and it's very handy way to get it. Let's kill this one. And again, for some reason, this does not update the screen anymore. Let's continue on the actual, no, wrong one again. Then a short thing about the iOS programming, like I promised in the beginning. My recommendation: start with the Movesense Showcase app. That was done maybe a year ago. We redid the whole Showcase app to be as good and kind of streamlined and finished as possible on the iOS side, because iOS was really lacking for anything usable as a sample. And the Showcase app is a kind of good basis for your own code if you want to start on that. The Showcase app is also available in the App Store, is it called in Apple? So you can just download it and access the sensor if you want, but the exact same app is available as a source code, and you can take that as a basis of your own application. In iOS, the REST API calls are very similar to the Android. Same applies to many of the other environments. They all have the same REST stuff underneath them. Connectivity API, I'm not sure. I haven't used the iOS MDS myself, so I cannot say for sure how it's done. But looking into that Showcase app sources and trying it out, then you know how it goes. Then something that has been asked in the past is the watchOS version of the MDS. It is not yet available. I have built a kind of trial beta version of it by hand, and it seems to work. But again, I haven't used it myself, so I don't know. I'm sure that we can dig it up from the old files if there's lots of demand for it. But that is something that is not kind of officially supported release yet. But that's about the iOS. I'm sorry I cannot tell you more. I'm sorry I cannot show you demos with it. I don't have iPhone. I did have a couple of years back, but I didn't like it. So I've been concentrating on Android side of things, hoping to get those done, lots of samples on that side to help you guys see how things are done, and that because that reflects pretty much on the iOS side as well.
Let's comment on the data transfer.
Okay, there's a question on the chat. Estimates how much the data transfer speed could increase for the next version. The estimate on that is that I'm not 100% sure if we can do it on the EEPROM data memory, the speed up. I do know that for the coming big memory variant, which uses the file system internally for store the logs, for that one the speed up is somewhere around 20 times faster. That's more or less. Meaning, especially on Android. On iOS, it has been quite a bit faster, so the speed up is maybe 5 to 10 times faster. Android. Sorry?
Android.
Yeah, no, on iOS phones, because obviously iOS has been faster. The problem with that is that it requires working also on the MDS side, for which we have our separate team here at Suunto, because Suunto internally use the MDS as well. And that means that cannot guarantee at which schedule it will be available or not. I know the sensor side can be included in 2.1, at least for the big memory variant. It could be that the MDS side will wait for some time or not, unknown at this moment. Is it a good practice? Okay, let's change the slide for one. So we are in the correct slide. So is it a good practice to connect to a Movesense sensor directly without scanning for its presence first? If it's MAC address, yeah, it's a good practice. I use it all the time when I do something simple. If I know the MAC address, I just use it, and that's it. And it's the easiest way to start by far, because even if scanning is not that difficult thing to do, it means that you still have to do it, and that's always those extra 50 or 100 lines of code that you have to test and make sure that it works and so on. Of course, if you're programming on Android Studio in Java, or with the iOS, you can always use our source code as the starting point and just start modifying. Take a copy, change the application ID, and start modifying it. That's the easiest way to do it. But yes, you can completely, in Android, you can directly connect to the sensor. About the connecting directly, also it means that when you have found out your sensor once, and if you know that your user is only using one sensor, then of course it makes no sense in scanning for it when you start your application. You can just call the connect directly, and if the sensor is not available, it will try to auto-connect to it when it is available. So you don't have to scan for it if you don't want. Okay, was there any?
Let's go back. There was this question, Alberto.
Yeah, Alberto Soto could be great registering events like start and end for season. How do you, could Alberto, could you clarify your question a bit so that you can even unmute yourself if you want to ask us over the voice. Okay, that's what I was asking. There was another one from Alberto.
Oh, okay. Okay, so that's...
Logging topic is great. Okay, so that was about the data logger. Yes. Excellent.
Okay.
Any more questions, please? Yeah, basically ScanBand can be used to connect a new sensor to the app when you want the user to select which sensor to connect to. Of course, it's a good idea to filter the list of the scan results based on your own sensors. You can do that, for example, if you order from us the OEM sensors, they can have their own name. Our samples, I think they filter with Movesense, but obviously since you can change the source code, you can change that. The scan can also be used if your sensors are transmitting something over the Bluetooth advertising packages. So let's say you have an application that for the most parts, the sensor just does something small, calculates some small value and sends it over the Bluetooth advertising. And then your phone can do that. And when your phone thinks that something important is there on the sensor, maybe in the data memory, it can do the connection to that. That is also one use case for the scan. For connecting multiple sensors, actually that is something I didn't show. Well, I only have one sensor here. All our Android samples support samples, not the showcase app. The samples support connecting to multiple sensors. Because of the UI reasons, the sensor apps and so on, they don't work too well with multiples. But the connectivity API, you can easily try to connect to 2 or 3 sensors and then do the queries there.
MAC address.
Yeah, if you know the MAC address of multiple sensors, that's all you need to do the connect. You don't need to scan. The DFU update process, yes, you put the sensor in the system mode 12, at which point it will boot up in the DFU mode, and then use the Nordic DFU library to do the rest. And one thing I forgot to mention at that point, good thing you brought it up, is that when you ask the info from the sensor, just like in the connectivity API sample, one of the things that you find in the info result is the DFU MAC address. The sensor will change the MAC address when it goes to DFU mode, but you can see what it will be in that info thing. For the iOS, not so simple. So for the iOS, the since the operating system does not reveal the MAC address of the Bluetooth device, what will happen is that you will have to scan and you will find the sensor advertising with the name DFU target, like target. So in iOS you have to scan. In Android you can shortcut and skip the scanning and just use the MAC address that the info gives you for the DFU mode.
So that tries to connect the same sensor twice.
Yeah. I think the best way to do that is to not call it twice, meaning keep track on which sensors you have tried to connect, and then make sure that you don't call it many times. We do have a connectivity tester app, which is downloadable from our mobile library site, which can run the multi-connection tests and disconnect tests for the sensors. If you want to try your phone to see if you have phone-specific issue or not, you can run that application with a couple of sensors. And it will do this kind of, you will have to install the correct firmware on the sensors for that to work, but then you can just do the app and it will run and give you the test results on how the multi-sensor connectivity and disconnects and so on work. But it's a good idea to just try out. The simpler the test case, the better. So the connectivity API sample is really great for trying out these disconnect scenarios and seeing how they work.
Kyllä katsotaan siitä hetken, mitä mä kaivan tuolla
Heinerille Okay, where can I get overview of end of slideshow? I'll take the slideshow off. Where was that? There was a question about the functionalities of the sensor.
Yeah, I'll get the link.
Yeah, if you can do that.
Yeah.
We went through the sensor capabilities yesterday in the sensor programming course, but yeah. But we have it in the movesense.com. There's Terho will find out the link to the data sheet, and you can download that and see how it goes. And there's a question about the data transfer speed optimization. Does it affect the connection times? And while doing that optimization, I did find a couple of things that can be improved on the BLE side as well. So hopefully the metadata exchange is a bit faster on the 2.1 variant, and that should affect both sensor hardwares, both the normal Movesense sensor as well as the big memory variant that is still in the prototyping phase. So yes, that will speed up as well. I haven't done any actual measurements on how fast it is, but it is faster that I can see. So maybe, I don't know, 50% faster, something like that. How long would a new sensor last if it's constantly connected to the mobile device and record data? I think you mean how long will the battery last, because the battery is changed. So it depends heavily on what you record. If you record ECG, the power consumption is around 130 microamps. If you record IMU9, the power consumption is closer to 1 milliamp. And then on top of that, you get the BLE transfer power use, which is around, depending heavily on how the Bluetooth connection is, but it's somewhere around 2 milliamps, 1 to 2. It could be a few hundred microamps as well. Depends on the data speeds and depends on how many packages has to be sent. So it's difficult to say. We have tested on the medical part of our medical certification. We tested that the full battery running ECG recording over Bluetooth lasts more than a week. But any info if anyone has used Swift Package Manager, the CocoaPods. I think that is a brilliant question for putting in the Stack Overflow and tag it with the Movesense. I'm sure there are people there that have used iOS, and that would, especially if you guys, if there's an answer to it, then everybody would benefit if the question is there. I don't know.
Also, I mean,
yeah.
Anybody from the participants? Do you have,
if
you have experience?
Yeah, if any of the participants knows answer to that, feel free to answer. What is the optional single channel ECG?
I guess that's in the data sheet.
The data sheet has it in all the Movesense variants at the moment. We have the single channel ECG. There's one difference is that in the sports variant, the measuring bandwidth has been optimized for the sports use to avoid muscle interference. And in the medical one, it conforms to the medical ECG standard. So it has much wider bandwidth. But both of them have the ECG data available. Any other question?
So Omar is just commenting that he's
some TensorFlow.
That is actually an interesting thing that I know that there have been some attempts or experiments of using running TensorFlow Lite on the sensor. So meaning that it allows feature recognition with the TensorFlow capabilities directly on Movesense, and that's a very interesting opportunity for all kinds of like detecting different movements and classifying activities, etc.
Yeah.
Okay. Looks like
today we were pretty much on the schedule.
Question chat seems to be getting a bit more quiet. We still have more than 40 people on the list, so that's very nice attendance, and hopefully this has been a useful session for everyone, and just keep the questions coming through the different channels. We will share the recording tomorrow. I will actually send an email to all participants with the slides and the recording links yesterday and today. And we will also have a little feedback survey to learn how to serve you better in the future sessions, and what kind of topics you would like to hear, and what are the things that we can do here to make your projects more successful and quicker and efficient and everything that you need. So thank you for joining, and keep working and stay in touch.
Yeah.
Bye bye.
Yep. Bye bye.